Okay, so today we're going to look at evaluating limits analytically, okay? I tell students if you see the word analytically or algebraically, those are essentially like the same kind of concepts. When you see an algebraic expression, let's say a function f of x equals x plus 2, then perhaps you plug in some value for x. If you see a rational expression, perhaps you're simplifying it and then plugging in, or you can plug in depending on what the value is for x. So there's so many different kinds of functions that you can look at in their algebraic expressions. Okay, so when you see analytically, maybe think analytically. Here we go. So jot this down. Number 1. If you understand the function and believe the limit exists by direct substitution, use that first. So that's essentially what I was saying with f of x equals x plus 2. It's a line, so every x there's a y. There's no holes, gaps, breaks, or anything. But if it's a rational function or a square root function, one of your other common functions that for every x you may not have a y, your domains are different, then you got to go to step 2. All right, so as you're listening, let me erase this, and we'll talk about step 2. Please copy down 1 and 2. Okay, so here we go. Number 2. If step 1 doesn't work, I discussed a little bit with where it doesn't work, let's say for a rational function, look at your function. If it is a rational function, then try simplifying it with either A, factoring, B, simplifying the complex fraction, or C, by using a conjugate. When we use a conjugate, we call this the rationalizing technique or the conjugate method. Okay? In each step of simplifying, it's meaning the function. You are changing its function, especially if you start like canceling or something like that, canceling factors. So what was f of x becomes g of x, and perhaps you're still simplifying, it becomes an h of x. So the limit notation has to, let me make this a c. It has to keep going every time you write a different function, okay? Here we go. What are we up to? I'm still in step 2. You will try to evaluate the limit of each simplified version until direct substitution can work. So let's say at this step it can work. The reason the other functions can be used to find the limit of the original function is because it takes on the same behavior. Okay? We'll talk more about the behavior of a function in a little bit, okay, in future lessons, but not right now. Okay? All right, so hopefully that makes sense what we're going to do to find a limit for some functions. And number 3, check your answer numerically. You don't need to show a check unless it does tell you to do so. Usually the words are approve, check, determine, verify, something of that nature. So we're going to do a few example problems. So we can understand that. So you get to see all the different types that we have. Okay, all the different types of functions we have. So I have 5 different functions. We're going to go through each of these examples. Okay, so for the first one, direct substitution does work. Okay, so the answer here is going to end up being 4 times 2 cubed, and that is 32. The next one, though, direct substitution does not work. If I did direct substitution, your answer does not exist. You get 0 over 0. Okay, so that's a side note. Loop that to the side. So what I'm going to do is factor the numerator and factor the denominator. If you factor the numerator and the denominator, you're going to see that you have factors you can cancel, and they become 1. Okay, so the limit of this expression here, as x approaches 2, is the same answer as what we have in number 2, and that becomes 4. Okay, so we're up to number 3. Okay, it's a little bit different than number 2. We can't maybe factor it until we see what we're looking at in our numerator. I'm going to take out that last slide. Hopefully you copied down the notes from that, and we're able to understand what we did for 1 and 2 in the meantime. Okay, so for number 3, we're going to multiply -3 plus h times itself. Distribute the 2. Now, some of you may be able to do this in your head and already get this next step. Now, I don't put equals because that means you're kind of evaluating something. So if you're not working vertically, which is the best way to kind of do it, do put arrows if you're working horizontally. So by distributing the 2, you're going to get 18 minus 18 in the numerator. Now, you don't have to factor out an h, but for some students it does help. You can see that these cancel. So the limit of this expression as h approaches 0 is the same answer as this limit here. So always show the substitution. I can't stress how important that is. When you have somebody reading your AP exam, they're looking to see if you can substitute where you're supposed to get the answer, okay? Otherwise, they don't know where it came from or where it's going, depending on what you're leaving on your paper. All right, so we're up to number 4, okay? So 1 was an example of direct substitution. 2 was an example of factoring. 3 was also, it's a little bit different than you're used to. There's where I kind of factored it, okay? They're all ways of simplifying. So number 4, we need to simplify our complex fraction. Okay, so 4 and 5 are going to need some space to do those problems. They're not as straightforward as 1, 2, or 3. So here we go. Some students do remember there is a quick way to kind of just cancel denominators in your numerator and denominator. We can't do that here. So you have to remember to do keep, change, flip. So keep the numerator as is. You can say it's over 1. Change division to multiplication and flip the fraction in your denominator. Okay. At this point, we're going to factor and cancel. You can multiply the numerators together and denominators together. So these cancel. And I kind of crossed out that 1. I'm sorry. It's a little hard to write on here. Like, that's supposed to be an M. I don't know what letter that looks like. So we have a new function. And in this one, we can plug in the 1. So if you plug in the 1, we get 3 times 2, so this is 6. Okay, so that's number 4. So you have to know how to simplify your complex fractions, and then that will help you find your limit. Okay, number 5. So this one is where we use a conjugate. It's called the rationalizing technique because most times you want to rationalize your square roots in the denominator. It doesn't necessarily have to be. Okay, so what we're going to do from here, our first step is to multiply by the conjugate. So that would be of the expression in the numerator because that's where your square root is. And you just change the sign between the 2 terms. Nothing else. What you do to the numerator, you have to do to the denominator, such that you're multiplying by 1, and anything times 1 is itself. So this expression becomes this one here. If you multiply, or I should say FOIL the numerators, do not do anything to the denominators. Leave them as factors. Okay. And the reason for that is because you're going to factor, it's a little bit of what we're doing before, and you're going to factor your numerator. For those of you who didn't realize, you're distributing the negative sign here. So the factors of t minus 4 with the quantity t plus 1 will multiply out to give you t squared minus 3t minus 4. Now, in this case, I factored out a negative from the factor in my denominator, but I didn't touch this at all. I didn't multiply. If anything, factor, because you're going to cancel factors. If you didn't see, you can cancel these factors. Ooh, didn't realize I had a tongue twister today. All right, so the limit of t plus 1 over t plus the square root of 3t plus 4 is going to help us to, as t approaches 4, because that's the same as the limit of this expression here, as t approaches 4. All right. Hopefully you understand what we did. I reviewed how to find the conjugate, just change the sign in the middle. I FOILed to get this. These factors are once I multiply these out. Okay. I didn't want to keep 4 minus t. I took out the negative. Okay. And I think I may have lost the negative. Did I? Let me double it. I did. The negative goes here. So if you're following along, you probably saw that I lost my negative, but it's back, and now we can substitute. So we're going to substitute 4 in for t. And when we do that, this is going to give us negative 5. And in the denominator, we're going to end up getting 8. So the final answer here is negative 5/8. Okay, so those are all the different types that I've seen where we can evaluate the limits analytically, as far as, in the AP exams, etc. So I'm going to give you some practice problems. Good luck.